This will be another problem, another hard one, another one that I haven't solved before. Let's see. So there is a 1 million by 1 million grid. Wow, that's a lot. And the coordinates of each grid square are x and y. We start at the source as x as y square. Okay, so I'm guessing we are getting the source, which is a list of integers, and want to reach the target, which is list of integers. There is also an array of blocked squares where each blocked represents a blocked square with coordinates. Okay, so blocked will be a list of lists of integers. Each move we can walk 1 square north is not in the array of blocked squares. We also are not allowed to walk outside the grid. Return true if and only if it is possible to reach the target square from the source square through a sequence of valid moves. We are returning Boolean. Well, what does it look like to me? It looks like a breadth-first search. The problem is the space. So let me just list challenges. Space. If we do BFS, how to store the visited squares, because it will be 10 to the power 10, sorry, to the power of 12 possible visited squares, which is not necessarily a problem, but still. What I was thinking about, like, the approaches solution, always work in the same direction, but that won't work because we are in a maze, not in like a big labyrinth with some blocked spaces. So what can we do? We can like so this is not working. We can theoretically, oh, we also need to just return true or false, right? But we also need to ensure that we are moving forward. So walk from both directions. But this doesn't change much. It just decreases the total amount of cells we need to explore. Okay, let me write some tests. I will mark as like 0, 0, normal, blocked, 1 start, 2 target. So let's just draw some and just for the sake of it, let's leave it like this, right? So if we start exploring, let's also say that we do it like this. I will tell you why I'm thinking about this. So the problem, right, is that we need to go here, turn around and go back. And that requires us to not create any kind of like a greedy rule that everything close to this start is already visited. So we can keep track of the frontier. Frontier will be like on the order of million, on the order of the size of perimeter of the square. So it's doable to keep the frontier of this BFS search in memory. And if we don't care about visited squares, we also can keep all the visited squares. And also there can be that many blocked squares. Let's actually see how many blocked squares are there. Yeah, there are at most 200 blocked squares. This is actually a very interesting thing. Only 200 blocked squares. Let me see, okay, the chat. Hey. Well, I don't have a video about what should one read to apply for those jobs, but I don't think that reading cuts it, to be honest. I think you should be solving problems to apply for the jobs, but nothing new. Okay, so the whole trick of this problem is that there can be only 200 blocked squares. And if there can be only 200 blocked squares, the only way to fully block our target is if we build a wall around either the source or the target. So how big should be this wall and how many elements might we at most need to, how many steps of BFS we might need to do? So the length of this wall can be at most 100. So we can do it, we might need to do at most 100 steps. It's like, okay, let me just draw this example. So if we have something like this, so 1, let's say that there is a start and then there is some line like this. So something like this is going for 100 steps, and then it's like this, right? So that's the longest it can be. And then we have to make 100 steps in total. So if we make, actually it will be like here we can have 99 and here we can have 99 and here we can have 1, right? Okay, maybe like this, right? So 0, that would still be blocker. So yeah, so if there are 99 cells, oh yeah, we can also start in the corner, right? So then it means that we can make at most 200 steps. So something like this in the corner. So we already are in the corner. Let's say we are starting in the corner and there are like 199 walls here, and then there is the 200th one here, so we can make it once like 200 steps. And if in 200 steps we haven't encountered, we still have elements in our border, then we are fine. And we just need to start both from the start and the target, explore for 200 steps. And once we explore for 200 steps, we will never encounter a border because we have exhausted all our blocking elements that we had. Okay, so solution will be BFS for 200 steps from start and target. And just to be clear, right, if we are in some situation like this, let's say we have this and we also have this, and then we have this again. That's basically us not using those blocks efficiently, because this way we will exhaust them faster. So we need to make even fewer than 200 steps to either ensure that we are actually blocked or move further away. What I was thinking just now, right? Let's say we have one, and then we have like the blocks like this. Do we need to make more steps in such scenario? More than 200 steps? If we are starting in the corner and we have all those zeros here, and then we can have 200 of those. But no, it will also be like 200 steps at most. In 200 BFS steps, we will exhaust this whole thing. Yeah. Okay. From start to target, if still have if frontier still non-empty, can reach. Okay. Now this sounds nice. Let's now figure out how to implement this. Oh, running time, right? So, well, since we're only making 200 steps, it's off 1, because we know that how many steps at most we need to do, so it's a constant time. But let's define length of blocked as n. So in such scenario, how many steps do we need to do? N squared of n squared in total, of n squared visited cells. And yeah, it will be n squared divided by 4 realistically, but doesn't matter, it will still be n squared. So n squared runtime and of n space, because the frontier will be of on the order of n. Yep. Okay. So implementation. Let's see. So we just need to implement the same function that does it, that processes things twice. Def check blocked and start, which will be a list of integers, and it returns boolean. Okay, so we start with double-ended queue, which will be the queue of start. And we do what? So actually we should do it like this. While dq and steps equals 0, steps smaller than 200. Will there be an off by 1 error? Let's just make it smaller or equal to 200, because then I think it should suffice. Okay, so I will just return here, return steps equal 200 and dq. So if we are at all our steps, while steps it will be 201. If we have reached the end and we still have an empty frontier, we will be returning true. And this is what we want to return. Check, let's call it check not blocked. For consistency. Okay, so now we just need to store directions. Will be a list of 0, 1, 1, 0, 0, -1, and -1, 0. For then we need to do what? For each element in range length of dq, we will do column row will be equal dq pop left. Then for d row in directions, yeah, we need to store visited. Visited will be a set where we just store tuple of start in the beginning. For dcdr in directions, we check. So first of all, it should be 0 smaller or equal to call plus dc smaller than 10 to the power of 6. And 0 smaller or equal row plus dr and smaller than 10 to the power of 6, and not row plus dr not in visited. And okay, another thing that we need to do, blocked set equals call row for in, okay, locked set, and this tuple not in locked set. If all of these happen to be true, then it means that we can visit it, and we will right away call it visited, and here we will be adding this element. Okay, we have added this. Now we can add it to our double-ended queue. Queue append the same thing. And once we have added everything for the length of our DQ, we made one additional step. So steps plus equals 1. And here, yeah, we already say what we are returning. And now finally, we just need to call this function twice. So if check not blocked source, yeah, basically return check not blocked source and check not blocked target. Yep, it looks like the whole solution, the whole implementation. How much time have we spent? 22 minutes so far. And I was answering for 1 minute, so let's call it 21, but I still need to check things. Yeah, the problem is that it will be tricky. Oh, I think there is one corner case, right? Like if we just encounter, yeah. If ends will be tuple of start, tuple of target, tuple of source, tuple of target, source, target. Let's make it a set. So if element in ends return true, because we might just, in such scenario as this, we will never have to make 200 steps. But if we have reached another element from here, we just can return true right away. So that was a bug. Let me just see if my implementation of BFS is correct. So steps, double-ended queue, directions, visited. Well, double-ended queue and steps smaller than 200. We started iterating over all elements that were added to double-ended queue in the last loop. And we do column row, we pop them, then we try all the possible directions. We check the borders, we check that we haven't visited this, we check that we can visit it, and then if either the column row is in ends, we return true. Why is that? Just to be clear, because we always add visited, like the element that we start from, we add it to visited, so we can never visit it again. So either like then if we start from the source, then we will check the target here. If we start from the target, we will check the source here, which is exactly what we want to do. Essentially, we will never get to the second iteration here. Or yeah, we could make it a little bit cheaper, but not improve the running time complexity by just like returning true here in such a way that we know that we don't even need to search from the target back to the source, because both of those things will be returning the same thing. But yeah, otherwise source. Okay. So just to make sure, let's say, oh yeah, oh no, oh actually yes, I was thinking incorrectly about this a little bit. I was assuming that we can have smaller total space, but we always have this big total space. How can we block? Is it just the issue with, like, let's say we have 400 here, 401, and we use this test case. Will it work then? No, it still doesn't work. So I'm missing something important about this. Oh, no. So what's the issue? So we should not be able to reach from source to target. And it looks like we are just drawing a diagonal, right? So 59, 60, 61, 62, 63, etc., etc., 78. Oh no, we are drawing the diagonal 60, 95, 96, 97, 98, 99. So we first grow it. Yeah, I still believe that it should be 200. I don't think that mistake is here. But it looks like we have... Yeah, this is the growing diagonal. Yeah, I cannot conceptualize what's missing here. I will... It's also very hard to conceptualize how to debug this. If I could just draw. I will just ask ChatGPT what is this geometrically. Geometrically. So actually I can just copy the whole thing. I thought that the test was cut. Perimeter of a diamond. Okay. So it's a diamond and not that big of a diamond. It's, yeah, just to 20, like 20, size of 20. So it seems that we are, for some reason, are not exhausting our steps. So, okay. Print steps. What? Okay, so we never get here. Oh. Why? Okay, yeah, I got it. I got what I have done incorrectly. Visited. I had incorrect assumptions about how this thing works. So will this work? No. Start 0, start 1, which will be in here, source 0, source 1, and another one, target 0, target 1. No? What? Print visited. So set just applies to all the elements, right? Okay, fine. Many assumptions about how things work that I shouldn't have made. Again. Okay, so I think now we have encountered an issue with our assumption about the number of steps. Let's see. Use this test case. Yeah, it's off by 1 error. So it should be more than, so 201. No, strange. Let's see, what's this? I want to understand it thoroughly, even though we already know what we should just do. I'm asking ChatGPT. Okay, so this if we start, okay. We should still be exhausting it in 200 steps. Oh, I see. Yes, I was wrong here. We are moving, like, no, we cannot move diagonally, so we are moving up to the right, up to the right. So this is my corner case, this one that I thought about, but I didn't understand it correctly. So what if we start here, for example, right? And then we need to do all of those steps and all of those steps. So it's like 200 plus 200. So that's why it should be 400. 400, and this should be 401. Plus or minus. Okay, yeah, it was mostly stupid mistakes and bad assumptions and not thinking through the corner keys that I thought about, but yeah, please just time limit exceeded. This is just BFS. And I just need to do like, what? Oh, I think it's just because of some load on the system. it might be right. Yeah, we are passing more test cases, but now it's like time limit exceeded. We have been passing more test cases before. How many, what would be the size of our 400 by 400? No, it's not too big. The number of steps that we need to make, n squared, 400 by 400. Yeah, it's essentially of 1. Okay, I digress. I will figure it out offline. For now, thanks everyone. See you later. Bye.